Yes, you're most welcome, ladies and gentlemen. We want to continue from where we ended last time. Today we want to look at the manufacture of chlorine gas. But before we continue with the manufacture of chlorine gas, remember, we say that for any industrial process, we always need what we call the raw materials. Before we can be able to integrate and we mix the raw materials to come up with procedures through which we can be able to convey them to get the desired product, which is chlorine gas. We shall first of all remember how to say the raw materials. Let us first list the raw materials for the manufacture of chlorine gas. Raw materials. One, in this case, we have concentrated sodium chloride solution. We have concentrated sodium chloride solution. It is also called brine. So whoever is watching the video should know that we have concentrated sodium chloride solution, which is brine. Two, we also have mercury. Mercury is also a raw material in this case. Three, we also have water. So those are the major raw materials we have. When we are having these raw materials, we also need to know what are we going to call the process of production. When we talk about the process of production, we are meaning how best can you be able to mix these raw materials in the chronological steps at the end of it all to get what we are calling chlorine gas. This process is done from within an industry, or else it can be demonstrated in the laboratory. However, you may not be able to get the chlorine gas you are interested in at the end, just in case. So we are talking about a large-scale production of chlorine gas, whereby in the process of production, we shall need all these raw materials, and the major raw material is the concentrated sodium chloride solution, which is also called brine. Now, in this case, what do you have to first do? This concentrated chloride solution, so concentrated sodium chloride solution, is the one that we are going to use, but we are going to put it in a certain vessel, and we call it the mercury cathode cell. This mercury cathode cell is the one that we are going to use, and that's where we are going to mix everything with outlets to allow gases to come out. Okay, so what are we going to do? We allow, this is under the process of production. We are going to talk, and you have to be able to understand what we are going to be mentioning. Concentrated, so the chlorine gas is obtained by electrolyzing, because we are going to carry out a process called electrolysis. So chlorine gas is obtained by the electrolysis of concentrated sodium chloride solution using the mercury cathode cell. That's where we are going to put that. Now, this concentrated chloride solution that you see, we are talking about mercury cathode cell. Mercury cathode cell, at the end of it all, your mercury is now acting as the cathode. So that is now a raw material. The reason why we call it a raw material, because at the end of it all, it works their side when it comes to obtaining sodium chloride solution. At the cathode, we shall not go for that. We shall be specifically on chlorine. Now, in electrolysis, of course, we have seen that this is the vessel we shall need. Concentrated sodium chloride solution is going to work as an electrolyte for this purpose. Then too, the electrodes, they are supposed to be two, the anode and the cathode. Now, our anode will be the graphite. So we shall use the graphite anode, and the mercury will act as our cathode in that case. That's why at the end of it all, mercury will further react to form sodium hydroxide dioxide that we don't want to go for right now. We are specifically on chlorine gas. Then the anode acting as your graphite. Then electrolysis proceeds. Of course, so long as you have the electrolyte, you have the anode, you have the cathode, it means that you already have the electrodes where the reactions can be able to take place. Now, in this case, you expect oxidation and reduction reactions to take place because this is now an application of oxidation and what? Reduction. Then at the end of it all, what is going to happen? During the electrolysis, as you allow electrolysis to take place, this is concentrated sodium chloride. So we have concentrated sodium chloride. It is in solution, meaning it gives what we are calling sodium ions and chloride ions. So it will give you sodium ions and chloride what? Ions. Now in this case, since this is a solution, concentrated sodium chloride solution, it means that there is also water. Better enough, also water is our raw material here, but there is also water here. So you expect water. This water you see here is a weak electrolyte. Since it is a weak electrolyte, it gives slightly ionizes in solution to give you what we are calling hydrogen ions and also hydroxide ions. This is what we have. So at the end of it all, we have hydrogen ions, hydroxide ions, we have sodium ions and chloride ions. So two positively charged ions and two kinds of negatively charged ions. At the end of it all, what will happen? We have the anode and we have the cathode. The anode, which is positive, and the cathode, which is negative. As you know, we all know that like charges repel and unlike charges attract. The positively charged ions are going to migrate or will be attracted by the cathode. The negative attract the positive. Then the negatively charged ions will be attracted to the anode, or the negatively charged ions will migrate to the anode. And they do so, discharging will take place. But if two positively charged ions, the sodium ions and the hydrogen ions, migrate to the cathode, which ions will be discharged? For us, what we are interested in, we're interested in chlorine. And at the end of it all, we are saying that at the anode, the negatively charged ions will migrate to the anode. However, the chloride ions, here we have chloride ions now and hydroxide ions. However, the chloride ions are going to be discharged preferably compared to hydroxide ions. Why? The chloride ions are more concentrated in this solution than the hydroxide ions. Therefore, in this case, the ions that are highly concentrated are the ones that are discharged. So at the anode, what do you expect to happen? We are expecting chloride ions to be discharged to give chlorine gas. So plus the electrons that we are removing. So I'll try to balance this one a little bit. We have that, and we have two electrons here. So this is the equation that takes place at the anode, and this is what we are having. We are producing chlorine gas, and it is formed at the anode. So we obtain chlorine gas through the process of discharging. Chloride ions. The hydroxide ions are not discharged here because the chloride ions are more concentrated than the hydroxide ions. At the cathode, discharging of sodium ions will take place because the sodium ions now are highly concentrated than hydrogen ions. That's when you form sodium at the cathode, but when we look at the manufacture of sodium hydroxide, we shall look at that in particular. But today we wanted the manufacture of chlorine gas, and this is what we have. So in simple terms, what have we looked at in summary? We have said that we have looked at the manufacture of chlorine gas. Begin with the raw materials, whereby we have concentrated sodium chloride solution, we have water, and we have mercury. Through the process of production, what happens is the vessel that we are using the mercury cathode cell. And what happens is chlorine gas is manufactured through the process of electrolysis. And we are saying that chlorine gas is manufactured by electrolysis of concentrated sodium chloride what? Solution using mercury cathode cell and graphite what? Anode. That's what we are talking about. During the process, so sodium chloride ionizes or dissociates in solution to produce sodium ions and chloride ions according to this equation. Since it is sodium chloride, it also has water. So water slightly ionizes in solution to produce hydrogen ions and hydroxide ions because water is a weak electrolyte. So in the solution, you will have sodium ions, hydrogen ions, chloride ions, and hydroxide ions. Sodium ions and chloride ions are more concentrated than hydrogen ions and hydroxide ions. Therefore, they are preferably taken for discharge. However, all the positively charged ions will migrate to the cathode and all the negatively charged ions will migrate to the anode. But at the end of it all, the ion which is more concentrated than the other is the one which is going to be discharged, just like we had. So that has been manufacture of chlorine gas. Remember, I told that you also have to remember what we call the social benefits of that manufacturing plant. Of course, if you are manufacturing chlorine and it is an industry, one, the workers, the people, the community members have to benefit through getting jobs. Therefore, you can say that the chlorine manufacturing plant is a source of employment opportunities, whereby workers in that industry get income, which help them to improve on their standards of living. Two, any manufacturing plant like the one with chlorine is a source of employment. So the government is revenue through the taxes imposed and can help the government to improve on infrastructures, among others. When you look at this process of production, you can realize that you are producing chlorine and you cannot say that you will not have any side effect. Therefore, if someone is going for this, you have to know that we have the side effects of the process of production. Not the side effects of maybe the product that you are producing, but the side effects of the process of during the process. What are you expecting? One, we are producing chlorine, and exposure to too much chlorine can lead to death. That's true. Just so you can be able to explain that point very well, among others, and you can be able to give the reasonable mitigation according to that. Of course, to mitigate any danger, personal protective equipment can be used. So before you go for the manufacture, be able to put on the personal protective equipment like face masks to avoid inhalation of the gas. Today we have ended there. Next time we shall come and explain what we are calling the mercury cathode cell. We shall have a diagram and we explain it, what we are calling the mercury cathode cell. We explain how where chlorine gas passes. Then we shall also explain what happens at the cathode. That's when we shall be dealing with the manufacture of sodium hydroxide. It has been a very good lesson today. I wish you the best.